Hi, welcome to the session by RouteFabric, and in today's session we're going to be going over aggregate types in Java. Alright, so the plan is first we're going to discuss what aggregate types are and where they are useful, and then we're going to talk about three popular aggregate types in Java, and then we're going to practice them in some code. Alright, so first, what are aggregate types? So aggregate data types are data types intended to hold multiple pieces of data, i.e. aggregate data together. So we've actually already used one popular aggregate type, strings, because if you think about it, a string is simply a sequence of characters, and characters are primitive data types, so we aggregate them together, put them all in one place, and we call this a string. So aggregate types are essential for programming. These are going to be used all the time. So there are many different aggregate types at our disposal in Java, already preset for us, and we can also define our own aggregate types, and we'll get into this later when we get to like object-oriented programming and that kind of thing. So we will be discussing strings, arrays, and array lists. All right, so arrays. So arrays are one of the most basic aggregate data types that you'll see. And basically an array is an aggregate type that holds only one type of data. So you can't hold different types of data, like you can't hold integers and strings, anything like that. It's one type of data, and it holds it in a contiguous format. So basically what that means when I say contiguous format, that means that the array elements are right next to each other in memory. So I've mentioned this before, but we don't really get access to memory in Java. We don't get direct access to the memory. So you might be thinking, okay, why does this matter? Why do we care about how the array elements are stored in memory? Well, if the array elements are right next to each other, what this means is that we can efficiently randomly access them. So we can really get data at any point in the array. So we can say, okay, find the data at array index 4 or find the data at array index 5. We can do that, and it'll give it to us. So this is also kind of a downside though, because since the memory is contiguous in an array, this means that the array must have its size predefined because it has to make sure enough memory is allocated to hold contiguously all those different pieces. It can't break it up in different pieces and link them together or anything like that. All the pieces of the array must be together in a single line. And so what that means is that your array can't grow. So whatever you initialize your array to, whatever initial size your array is put, we can't go past that. So if we have an array with 4 elements, we're always going to have 4 elements. We can't say, okay, we'll make a 5th element and put that in it. We can't do that. All right, so arrays are built into the Java language, and we can use them, right off the bat. And they are denoted with square brackets before a variable name declaration. So for example, here we have like int, and then we have, sorry, let me go back real quick. We have int, and then we have our variable name, mynums, and before that we have brackets. So this is saying this is an integer right here. This is an integer array. So there's a couple of different ways we can, there's a couple different ways we can declare an integer array or any type of array. We can either explicitly set values for each one. So here we say int array mynums, and we're going to set it to 1, 2, 3, 4. So this is an array with 4 different elements, and they have the values 1, 2, 3, 4. So this is one way you can do it. You can also not set any default values, and you can just declare the size. So either way works fine, as long as the array is able to deduce the size. So here the JVM can deduce, okay, well the size here is 4 because you've given 4 elements. And here it'll say, okay, well the size is 20 because you've specified explicitly, oh, I want 20 elements. But if we were to do something like int brackets mynums and then just leave it like that with no size specified, we would get an error there. Because like I said, arrays need the size specified before they can be made. So whenever an array is made, whenever it's initialized, the size must be given to it in some way. So we can do it this way or we can do it that way. Either way works fine. Also, just a little side note is arrays can be multidimensional with the inclusion of more than one square bracket. So you can do, for example, 2 square brackets, and then you have a multi-dimensional array. You'd have a 2-dimensional array there. So you can have both rows and columns if you wanted to do that. And the memory is still stored contiguously, that kind of thing. You just need to make sure you specify, of course, a size for both dimensions of the array. Again, so you need to make sure it's able to deduce the size. All right, next, another popular aggregate type is strings. So we've actually been using strings for a while now, and we know that strings are basically an aggregate type that hold specifically characters. So in a string, we can hold anything that can be interpreted as a character can be held within a string. So strings can shrink and grow as needed. So this kind of sets them apart from arrays. And this is done all within the string class. We don't have to worry about this. The memory allocation and the memory reallocation and stuff like that for when it needs to grow is all done within the string class. So we can just use strings. And we can declare a string by either making a new string object or by Java string literal. So I know that sounds kind of confusing. What does that mean, Java string literal? But I'll explain the difference real quick. So when we're using a Java string literal, a new object will only be created if necessary. Otherwise, the string we define will just be assigned to an already existing object. So this is done for memory efficiency. So basically, we do this when we say something like string name equals Lucas. So this would be a Java string literal because we're not creating a new string object necessarily. The JVM could decide to make a string object, but we're just saying literally create a string and then put it wherever it needs to be put. So we're letting that be decided up to the JVM. But whenever we use the new keyword, then we know that a new string object will always be created. So when we do something like string name equals new string, and then in the constructor we put, Lucas or whatever, then we know a new string object will always be created. So really, you can use either or, it doesn't really matter. If you definitely need a new string object and you definitely want its own individual object, you want to use the new keyword. Just a note here, since strings are essentially character arrays with special methods and properties, that's really all a string is, and of course, special memory allocation, we can easily convert a character array into a string. So this is a cast we can do implicitly pretty easily. Also note, strings have many, many methods at our disposal. We can do stuff like uppercasing characters, we can do substrings, we can remove and add characters. So basically what I'm trying to say here is I encourage you to look at the documentation available for strings in Java and see what you can find, because a lot of times people will be starting out and they'll be making a program and they want to do something to a string and they wonder, okay, can I do this or do I need to write my own method for this? What can I do here? And it's always good to just look online and see what methods are available, because more often than not, the the functionality that you need could already be included, and then you can just use that. All right, so array lists. So an array list is a class provided for us in java.util.arraylist. So again, we can either include all of java.util or specifically just ArrayList. So an array list is similar to an array, but it can shrink and grow dynamically. So what this means is that, we said with an array, the size is set. So whatever size we set it to initially, we can't grow past that. However, an array list can grow dynamically. So if we want to add like a fifth element when we only said, hey, make 4 elements, we can still do that, and and the array list class will handle all that for us. So array lists also put data in a contiguous format so we can randomly access it. So this is where the array part in array list comes from. Basically, it stores it as if it's in an array. So it stores it contiguously, just like an array, so we can access any index in the array. Array lists can also only hold one type, and we have to specify the type. And array lists can also be multidimensional because you can make array lists of array lists. So if you want to, you could have a multidimensional array lists. And also just a little note is array lists can be created with or without a size, an initial size, I should say. So we can create an array list with an initial size of 5. If we think we're only really going to be using 5 elements, we can do that. And if we end up needing more, it'll grow dynamically. But either way, an array list can grow and shrink dynamically. And keep in mind, if we don't give an initial size, the JVM will choose an initial size for us. Most of the time, this is going to be 10, but depending on your version of Java, that could differ, that kind of thing. All right, so let's go ahead and jump straight into coding so we can practice these. So we will create a simple program to store students' names. So what we'll do is we will continuously prompt the user to enter names until exit is entered, and then we will display all of the entered names. So we'll be prompting the user, okay, enter a name, enter a name, enter a name, and then once we're done and we enter exit, we'll just list all the names. All right, so we'll just go over to our Eclipse workspace and we will create a new class and we'll just call this names or something like that. All right, so we should include the Arraylist package. So we'll just do imports java.util.ArrayList. Perfect. All right, and then we're also going to need a main method because we want this to be executable. So we do public static void main string. Perfect. All right, perfect. So now we're going to so since we want to prompt the user continuously, we know we're going to need a while loop here. So we can do we need a while loop here. We also need an array list to hold the names. Now, why do we need an array list? Well, we know we're going to need an array list because we don't know how many names are going to be entered. Since we're using a while loop here, we don't know if that while loop is going to be run just once, or maybe it's going to be run 10 times, or maybe 50 times, whatever. So we don't really know how many names the user is going to input. So here we're going to need to use an array list. So we'll just call this, we'll do array list, and we just specify the type. So we'll hold string, and we'll call this names, and then it's going to be new array list string. All right, cool. So as you can see here, we're creating a new array list, and it's going to be holding strings. So we specify the type we want you to hold is strings. We just called it names, and we set it to creating a new array list. And you'll notice parentheses here. You can include a default size for your array list, like I mentioned. So we can do 5 if we want to. I'm just going to leave this blank because we don't know how many names the user is going to enter. So we can just leave that blank. Really doesn't make a difference in this use case. All right, and then we're going to do string response. And we're going to use a do while loop here. So we'll do while response.content equals exit. I'm going to put a not. So while the response is not exit, we're going to continue to run. All right, perfect. And then we're going to get an error because the response is not initialized, but we're going to do that in here. We should also import the scanner class because we need to use that. So import java.util.scanner. And we'll set up a scanner too. So scanner in equals new scanner system.in. Perfect. So we're going to do response equals in dot next. So the next string. We should prompt the user too, just to make this look a little bit nicer. So we'll do system.out.print. Please enter in a student name. All right, perfect. And then we should close our scanner somewhere down here as well. So we'll do in.close. And then we're going to need to add our names to the array list. Then we're going to do names.add. We're going to do response. Perfect. All right, so if we were to run this right now, we get about half the functionality. So you'll see it'll just ask us for a student name. We can put anything in here. We can put, say, John, Carl. It'll keep prompting us until we type in exit, and then it'll exit the program. So now we also want to be able to print out all of the names that we've saved. So now we'll just do that real quick. So we're going to do print out the names in the array list. So we can do a for loop for that because since an array list, we can get the size of it. We don't have to do a while loop or anything like that. So we'll just do int I equals 0. I is going to be less than names.size and I plus plus. And we're going to do system.out.println. And we're going to do this, and then we'll just concatenate with names.get. We'll do I. Perfect. All right, so if we were to run this real quick, we'll just save it and run it. We can have the same functionality as before, so we can enter in our name. So we can put like Carl, Stacy, whatever, and then when we press exit, it'll exit the while loop, and then you'll see it'll put all our names out. And you know, you'll notice we have a slight oversight here. We said that exits, we actually added exit to the name. So what we need to do here in order to prevent that is we can prevent that pretty easily. We can just add an if statement. So we can do if response.content equals, and we'll do here exits. And then we will add a not operator here. So basically, if the response is not exit, then don't add that to the names, because that's clearly not meant to be a name. No one is named exits. So then we will run this again, and we can do the same thing, John, Stacy, whatever. And then if we press exit, you'll see it'll print out all our names for us. So we have John and Stacy. All right, so I hope this lesson was informative. If you would like to learn more about aggregate data types in Java, you can check out our lessons at RouteFabric.com. Thank you.